We would like to provide you with an overview of what we have learned so far about the hydrology and hydrogeology of the Indian Point Nuclear Generating Station. In September 2005, leakage of contaminated water from a crack in the Indian Point Unit 2 spent fuel pool was discovered during upgrade construction at the plant. Water from this shrinkage crack in the concrete pool wall was sampled and tested for radioactivity. Radionuclides characteristic of spent fuel pool liquids, primarily tritium, were identified. Immediately after this discovery, Entergy began extensive efforts to determine the nature and source of the leak and resulting groundwater contamination. GZA has been performing a comprehensive hydrological and geological assessment of the site. Investigations included the review of existing geological information, installation of a series of groundwater monitoring wells that were then equipped with special instrumentation to collect data. Monitoring well installations required special drilling equipment to work inside the spent fuel building directly below the crack location. Additional specialized drilling equipment was required to gain access to the required monitoring well locations within the basement of the turbine generator building in close proximity to tightly positioned sensitive power transmission equipment. The drilling equipment had to be powerful enough to penetrate the hard bedrock formation below the power plant. The data was then evaluated to develop a conceptual model of the groundwater flow at the power plant property and the surrounding region. The objective was to identify the extent of contaminant migration from the spent fuel pool and its current and future flow path. Because the plant was constructed in a depression excavated out of the bedrock on the banks of the Hudson River, the conceptual model predicted that groundwater should flow towards this depression in the bedrock from all sides, except from the river to the west. The model further predicts that groundwater, once on the site, should then flow into the Hudson River. This is because groundwater must flow from high groundwater elevations to lower groundwater elevations. The elevation of groundwater in the areas where tritium has been detected is lower than the elevation of the surrounding groundwater, but higher than the surface water in the Hudson River. Therefore, groundwater from the region flows downhill towards the site from all sides and eventually makes its way to the river. Also, groundwater flow rates in the bedrock below the plant were determined to be low because fractures, which create pathways for groundwater flow in the rock, were limited. This conceptual site model has been verified through monitoring at over 35 multi-level wells on the site, as well as sampling groundwater at a number of points off-site on nearby properties. Laboratory results from the off-property samples analyzed by Entergy and the Nuclear Regulatory Commission and the State of New York Department of Environmental Conservation have indicated no detection of radionuclides over years of sampling. In summary, results of laboratory testing to date have indicated tritium levels are highest near IP2 spent fuel pool and IP2 transformer yard. Lower levels of tritium were found in other locations, including low levels in some storm drainage systems. However, these tritium levels are below drinking water standards as set forth by the U.S. Environmental Protection Agency and would be considered safe to drink. Strontium has been found at elevated levels in the vicinity of Unit 1, which has been shut down for a number of years. Samples from off-site monitoring wells continue to show that no detectable levels of tritium and strontium can be found in the off-site groundwater. Drinking water for residents of the area is provided from surface water reservoirs and not groundwater. Moreover, these reservoirs are located over 3 miles away and at elevations hundreds of feet higher than the groundwater plume. We continue to analyze groundwater flow patterns at the site by collecting data from over 35 multi-level monitoring wells on a current frequency of monthly to further verify our conceptual site model. Results to date indicate groundwater movement on site is: number 1, influenced by past construction activities, including the discharge canal. Number 2, generally toward the nuclear power plants, not away from the plants. Number 3, generally from the north, east, and south towards the west and the Hudson River. The results of the groundwater investigation have indicated that there is no significant human health and environmental impact as a result of the inadvertent release of the radionuclides into the groundwater. The study to date has shown: number 1, no radiological contaminant migration to drinking water supplies. Number 2, no radiological contaminant migration to surrounding properties. And number 3, potential groundwater flow to the Hudson River is a small fraction of natural background levels for radioactivity. In fact, it is less than 1/1000th of public health and environmental regulatory standards. What's next? Finish development of the third and ongoing phase of monitoring well installations to further refine the conceptual model of groundwater flow. Conduct tracer tests using specialty tracer chemicals that are designed to be safe to add to the groundwater so that we can analyze the underground movement of these water-soluble chemicals in the groundwater. This may help us predict the movement of tritium in the groundwater. Continue the groundwater sampling program and evaluate the trends in the levels of radionuclides and the location of these radionuclides in the groundwater. Evaluate the remedial action steps required to reduce the levels of radionuclides in the groundwater.